Hello everybody, this is Scott Armas. Today I want to show you a new experiment using the 3D touch screen of the iPhone 6s. Now these are the measurements, and you can see that it goes up and down quite a lot. And that's because the increments here are quite large. You have many digits, but the smallest increment is 0.81. Yeah, there you saw it. But if your samples have different masses, then they can't all get trapped in between two such increments, and that way the composition dependence can still be seen as a slight upwards trend. But of course, this is not very practical as a material analyzer, of course. But it doesn't matter, it's just a proof of concept here. So let's test a few materials. So the weight that shows with the spoon without putting anything on is 4.05. And then it goes up a little bit for a moment. So anyway, if you put something on, you always take the initial value. So 1461, and here what's the element here? Thulium. Okay, TM 13.8. Let's try it again. Yeah, 13.8 is the initial value. Yeah, 13.8. We always take the minimal value, of course. And let's try a few more. This is erbium. So let's use erbium now. (13.8) erbium. Where is erbium? Here 13.8. Yeah, that's correct. A few more. What's this here? Tantalum. Okay. When I did the original measurements, I was putting the spoon there first and then the sample, but well, it doesn't really make much of a difference. So, okay. 20.29. Is it? Yeah, tantalum TA. Where is it? 20.29. Okay, now I forgot again what it was, but I think it was that. 20.29, yes, that's correct. Let's also do this very heavy one. This is mercury. Okay, it's very hard to do something and hold the camera at the same time. Okay, so this is mercury. 21.10. Hg 21. What was it? 21.10. Yeah, let's measure again. Okay, 20.29. Yeah, that's what is written there. Yeah, well, it goes up a moment after. Yeah, but that's basically it. Yeah. So it's stable for like 10 seconds, 15 seconds, and then climbs up a little bit. but that's okay. We just take the lowest value, and if they're all lowest values, then they're all treated equally. Okay, so I also did some common household materials here, like oil, water, sugar, rubber, lead, glass, salt, zinc, iron. Yeah. But yeah, you get the gist of it. And the next step will be to use a piezo sensor, or there are things called piezo resistive sensors. So I'm going to look into that. And then we will see if we can get graphs that are smoother than this, like a lot smoother. Yeah, but this is really only one trial for each. Like I measured twice for each to be sure that that's the correct value, and it's very very consistent. Like you get the same number every time you measure. You measure at on a different day, different temperature. It's still the same value. Of course, the resolution is not very high, but at least it has many digits, and so when you have different masses, then the composition dependence crystallizes out at the end. If you have only a few samples, then not so much, and if you have heavy samples, that's not so good, because there's quite a little bit of a non-linearity here in this touchscreen based scale, so that you can really compare measurements in the range of 10-20 gram with things you measure at 100 gram. So these are all at about 5 to 10 grams. Okay, that's all I have for today. See you.